Welcome back, guys. In this video, we're going to be solving these very problems on gamma functions. Now, this is actually from University of Benin also, and I think there was a particular year, I can't really remember the year, that I gave some questions. I gave 50 questions to the students, and they stepped into the exam and answered exactly those same questions for like 2 to 3 paper types. And the lecturer started doing something. So what he started doing was to multiply by constants. So first of all, whenever you're answering questions from EMA 382, the equations from the integral function part of it is always the same. So what he started doing in recent years is to multiply by constants. So what you then notice is all of these integrals are kind of the same. The only difference is there's a 2 in front, there's a 6 in front. So let us just solve this problem. I'm going to solve just the first one, and then we can just multiply to get the number 2 and number 3. So let's start with the first one. So for the first one, there's x squared. So let me just write number 1. So we have the integral from 0 to infinity, x to the half, e to negative x squared dx. Now, remember that from earlier videos, I've showed you that you must always have your exponential raised to just x minus x. But in this case, it's even much more complex because we now have x squared. You shouldn't have x squared. You should just have x. You should just have x. So let's say u equal to x squared. So let u be equal to x squared. Now, if u is equal to x squared, I could actually, make s the subject, because whenever you're making a substitution, every other thing is going to change. So since I'm introducing u, every single thing here is going to also have u. So let's say that to remove square, we have to take the square roots, right? So if this is 2, the opposite of 2 as a power is 1 over 2. So this is u to the power of half equal to x. Or you could just take the square roots of both sides. It's still the same, because when you take square roots mean the power of half. The reason I did this is u is equal to x to the half, to the 2. So if I multiply both sides by 1 over 2, the 2 here we cancel out the 2, so it means u to the power of half is equal to x. So I feel like it's just much more better and saves me time. Okay, so u to the power of half is equal to x. Now, how do I find my dx? Can I get my dx? Of course I can. If u is equal to s squared, this tells me that du, when I differentiate, s squared will give me 2x. And then I'm going to put my dx. Yeah, of course, remember that I've earlier showed you why this is correct. If u is equal to s squared, du dx will be equal to 2x. But to save myself the stress of always doing du ds, I could just say that when I cross multiply, du times 1 is du, then ds times 2x is 2x dx. So that's just same answer as that. But as you can see, I have an extra layer. So it's still the same thing. Instead of doing this, I'll just say this. So it's still the same thing. Remember to hit the subscribe button, like this video, and share it across to your course mates. Okay, now we're trying to make ds stand alone, because this is just dx. So we're trying to make ds stand alone. So we're trying to make ds stand alone. So we're going to divide both sides by 2x. So this should be du divided by 2x equal to dx. Our main objective is to make sure that all of the x disappears and only the u remains. So this is x. It shouldn't be here. This x shouldn't be here. So this is du divided by 2. Remember that x is what? S is equal u to the power of half. So that's u to the power of what? Half. Equal to what? Dx. And with this, we've been able to do every single thing that we need. So we need this guy, we need this guy, and we need this guy. Now, how would all of these all come together? So let me write the integral. So this is the integral from 0 to infinity. And this is x. But remember that x is now u to the power of half. So this is u to the power of half. And then what's the power outside? We'll have another half outside. So I'm going to say times the half that's outside. Then this is e, so minus, what is x squared? S squared is just u. So this is u. Then what is dx? Dx is du divided by 2u half. So we have du divided by 2u raised to the power of half. Remember that the main idea is all of the x should go away. And as you can see, all of the x's, they're all gone. So this will be equal to integral from 0 to infinity. We're going to have u. Half times half is a quarter, 1 over 4. Then e, so negative u du, divided by 2u to the power of half. Yep, to the power of half. Now, what am I going to do next? I could actually take this u to the power of half. So this very u. Yeah, I could actually do that. And then the 2 can come outside. Here's the thing. Every single thing here is a numerator. And this is actually a denominator. Remember that if you are dividing in indices, when you are dividing, my writing looks kind of bent. So if you are dividing in indices, what you do is you're going to subtract the powers. So this is the 1 over 2. The 1 over 2 is coming from this very 2 here. 1 over 2. Integral from 0 to infinity. Then we're going to have u to the power of 1 over 4 minus 1 over 2. If you are dividing 2 guys, you're going to subtract the powers. Then e to negative u du. Okay, that's looking fine. So this is 1 over 2 integral from 0 to infinity of u. What is 1 over 4 minus 1 over 2? That's negative quarter. That's negative 1/4. Look at it here. 1 over 4 minus 1 over 2. LCM is 4. 4 divided by 4 is 1. 1 times 1 is 1. Minus 4 divided by 2, that's 2. 2 times 1, that's 2. So 1 minus 2, that's minus 1 over 4. So that's minus 1/4. So minus 1 over 4, e to negative u du. Now, as you can see, this is the reason why sometimes, if you notice, in earlier examples, I've always been giving you the answer right instead of factorial, like very fast. But currently, you're not going to do that. Yeah, you're not going to do that. It's not going to happen. So why can't I do that in this case? You notice that this is actually minus 1 over 4. So I can't go about and start saying minus 1 over 4 factorial. So what we're going to do is, let us represent this in terms of gamma, because gamma function is an extension of the factorial. So notice how we cannot actually say minus 1 over 4 factorial to get an answer. But if we write it in terms of gamma, an answer is going to be coming out. We're going to have an answer. So let's see. So this is 1 over 2 gamma. Now, what gamma would this be? What gamma would this be? This will become, remember that, yeah, let me come back here. If you're moving from this point to this point, you're always going to be adding 1. So from this point to this point, you're going to say plus 1 because this is just x. In this case, we have minus 1 over 4. Minus 1 over 4. So if you want to write it in terms of gamma of something, you're going to say that very number you got plus 1. So this will become minus 1 over 4 plus 1. If you want to write it in terms of gamma. It is when you want to just write it in terms of factorial. That's when you just say x factorial from here. But we cannot be saying minus 1 over 4 factorial. It doesn't make sense. Okay, so this is 1 over 2 gamma of, now what is minus 1 over 4 plus 1? That's 3 over 4. Now how did I get that? Minus 1 over 4 plus 1 over 1, because 1 over 1 is still same thing as 1. Then the LCM here is 4. 4 divided by 4, that's 1. 1 times minus 1 is minus 1. Plus 4 divided by 1, that's 4. Times the 1 on top, that's 4. So minus 1 plus 4, that's 3 over 4. Now, for students in the University of Benin, you will always be given a value. Yeah, you're going to be given this very value in the exam. Now, there's a table that the lecturer always draws. I am going to treat this table also. Now, this value is a special value. So that's 1 over 2 times 1.2254. 1.22. It's a special value. So you're going to be given in the exam. So 1.2254. Now when you take the half of this, it's going to be giving you a kind of nice number. I think 0.613. Sorry. I think it's going to be giving you this number. Or let me put 27. I think it's going to be something like this. Because when I double this guy, 27, I'm going to have 54. Multiply this by 2, I'm going to have this. And then, yeah, that's what it's going to be. 0.6127. Now, you can see that we've gotten our answer for this very problem. But in the exam, you could be having the ones that have 2, the ones that have 6. So let us just do them. So this is question 2. Question 2 says the integral from 0 to infinity, 2x to the power of half, e to negative s squared dx. Like I said, this is the only new thing is there's a 2 here. So this is just 2 times 0.6127. So when I do this, this will just give me 1.2254. That's just what it's going to give to me, 1.2254. When you multiply. Now for the third one, for the number 3, the integral from 0 to infinity of 6x to the power of half e to negative s squared dx. Now the answer for this, remember that the 6 is a constant, so you can just write it outside. So this is 6 integral from 0 to infinity, x to the power of half, e to negative s squared dx. Now this is 6 times. What answer did we get for this? The answer we got for this is 0.6127. So let us multiply by 6. Hold on, there's a better way to do this multiplication. Since I have no calculator with me. I've already multiplied it by 2 previously. So if I multiply 3 by 1.2254, I should be able to get my answer. So let's just do this. So this will give me 2 carry 1. This is 15. So this will be 16 carry 1. This will be 6, so that's 7. This will be 6, and then this is 3. So we're likely going to be getting 3.6762. You can check that with your calculator. If there's an error, I'm going to kind of edit it. But so that's what we have. So this is how to solve this very problem. And as you can see, it's actually easy to solve. So this will be all for this very video. Remember to hit the subscribe button, like this video, and share it across to your classmates. Subscribe.